Hello, this is Mrs. Ross, and this is Lesson 4, Number Line and Sequences, Starred Problems. These are the starred problems from the written practice, and we're using Saxon Course 2. Alright, so if the minuend, as soon as I see this word, I know that we're talking about subtraction. So what I'm going to do is I'm going to come over here and write my many minus sharks over died, and then I can fill in the blank. So it says the minuend is 27, so I have 27. The difference, which is the answer to a subtraction problem, is 9. So I don't have my subtrahend, and I know that this is 9. So if I write this out horizontally, I see that my variable is in the second spot. And the rule when my variable is in the second spot, this being the first spot, my rule when the variable is in the second spot is that I subtract. And I get S is equal to 18. Or subtrahend is equal to 18. What is the name for numbers that are greater than 0? Positive. Evaluate each expression for n is equal to 6 and m is equal to 24. So wherever there's an m, I'm going to put a 24. Wherever there's an n, I'm going to put a 6. So 24 minus 6 is 18. Here I have 6 minus 24. Now I know that this is going to be the opposite of this. So I don't even have to redo the problem. I just know that it's going to affect the sign. So I get negative 18. Here I have m, which is 24, over n, which is 6, which gives me 4. And then, of course, when I have m and n together and there's no operation, that means multiply. So I have 24 times 6, which gives me 144. All right, number 5. Use digits and other symbols to write the product, so this is multiplication, of 5 and 2. So I have 5 times 2 is mathematical language for equals. So is greater than, is greater than. So this is going to be, the monster's going to eat this one instead of the other one. The sum, so disregard this for right now because it says is greater than. I didn't read far enough. The sum is addition, so I have 5 plus 2. So I'm going to put 5 plus 2 over here. Let's see if that's correct. So I know 5 times 2 is 10, and we're saying 10 is greater than 5 plus 2, which is 7, and that is correct. All right, arrange these numbers in order from least to greatest. Now if you look at our number line right here, you'll see this is the greatest and this is the least. Okay, so if something's more left, it is smaller than something that is more right, if that makes any sense. So let's see, I have -2, 1, 0, and -1. So on my number line, the one that's the furthest to the right is 1. So that's going to be my greatest. It says least to greatest, so least to greatest. And I'll cross that out. The next one is 0. The next is -1 and then -2. So least to greatest is here. I'm going to go ahead and erase this so we can use it on number 8. Okay, so let's do number 7. If you know the divisor and the quotient, so this is the answer to a, oops, what happened? Okay, this is the answer to a division problem. How can you find the dividend? Complete the sentence. So let's see, is its dividend over divisor is equal to quotient. So it says if I know the divisor and the quotient, what is the dividend? So if it's like S is equal to, let's do that. So if I'm trying to find if the variables on top, if we look back to our rules for how to solve for unknowns, if our variable is on top in a division problem, we're going to multiply these two things. So 5 times 3 is equal to 15, which is equal to s, and that works out. So my answer to this question would be that I multiply the divisor and quotient. My handwriting is atrocious. All right, let's pick a different color and move on to number 8. This says show this subtraction problem on a number line. Again, I want to reiterate that I'm not a big fan of the number line subtractions. I think that you guys have a better way of doing this, but I'm going to show you how to do it in case it helps somebody in the class. So we always start at 0, and we're going to go to 2, which is right here. And then since we're subtracting, we go to the left. So we're subtracting 1, 2, 3. So this is my answer, -1. All right, find the value of each variable. So number 9, 12 times x is equal to 12. So 12 times something is equal to 12. I can divide and get x is equal to 1, or I can use the identity property and say, what times 12 is equal to 12? 1. So on 10, I'm going to want to add all of the numbers over here together before I start to solve. So 4 plus 6 is 10, plus 8, I get 18, plus n is equal to 30. And then I'm going to subtract 18 from both sides. So let me show you what that looks like over here. Remember, we're doing the opposite operation. Right now we're adding 18 to n. We're going to subtract it. What we do to one side, we do to the other side. So this is going to cancel. My n is going to come down. My equals is going to come down. And I get 12. Okay. Number 11, z minus 123 is equal to 654. So I saw earlier in my starred problems that if the variable is on in the second place, I subtract. But if it's in the first place, like it is here for number 11, I add. So I'm going to add 123 to both sides, because subtraction and division are a little bit tricky. This goes away, my equals comes down, and I get, let's add this, 777. Okay, and we have an opportunity to practice that on 12, where I have the variable in the second spot here. Okay, so I'm not going to solve 12 like I did 11, even though they're both subtraction problems. It's it's because the commutative and associative properties don't work with subtraction or division that we have special cases there. So since this is in the second spot, that means I'm going to subtract. I kind of remember that because they both start with S. And I'm going to do that on my handy dandy calculator. 899. All right, let's keep going. Okay, number 14, we've got 32 times k is equal to 224. Whenever you have something times a variable, you're going to divide without question. Multiplication and addition, it's the same thing no matter where the variable's at. So 32 divided by 32 is k. And then I have 224 divided by 32, so I need to do that division. Divide by 32, and I get 7. Oh, where's my little dot? There you are. I get 7. That's my answer. And then here on 15, I have a division problem. And like I said before, division problems are kind of weird as well. But if my variable is on the top, I'm going to multiply. And if my variable's on the bottom, I'm going to divide. Right now my variable's on the top, so I'm going to multiply. R is equal to 8 times 24, which is 192. All right, let's do 16. It says, look at the first and second steps of solving this equation. Justify each of these steps. So step 1 is just the given equation from the problem. 4 plus parentheses 9 plus, or n plus 9 equal 20. And so what have we done between step 1 and step 2? we've changed the order here. Did we change the parentheses? We did not. It's just the order, so that's the commutative property, and we're adding, so this would be of addition. Okay? Now from here to here, we changed our parentheses from here to here. So we did change our parentheses, and that's associative property, and we're adding, so of addition. And that's all we need to fill in there. Let's move it on along here. Having trouble getting, there we go. Okay. Replace each circle with the proper comparison symbol. So before we do that, it looks like we have to do some operations for A. So 3 times 4 is 12. And then 2 times 6, when there's not an operation between these two, that means it's multiplied. That's also 12. So this is equals -3 and -2. So on my number line, -1, -2, -3, this one is less than this one, okay? Because the more right you go, the bigger the numbers are. Here we have 3 minus 5. So if I flip it to 5 minus 3, I get 2, but when I flip it, it has to have a negative sign. So the positive 2 is going to be greater. And here I have x and y and x. How am I going to figure this out without any numbers? Well, they're kind of trying to show you that this is actually, they're equal. So if I said x is equal to 1 and y is equal to 8, then I know 1 times 8 and 8 times 1, and I get 8 equals 8. So you can always put numbers in and kind of check your work. All right, last two problems. Use the numbers 2, 3, and 6 to illustrate the associative properties. So this is parentheses of multiplication. So you could do 2 times 3 times 6 is equal to 2 times 3 times 6. And you'll see that my order remains the same, but my parentheses are different. So this would be 2 times 3 is 6 times 6. And this is 2 times, this is 18. And then I get 36 is equal to 36. So that checks out. Okay, last problem. Use words to describe the rule of the following sentence or sequence, and then find the next two terms. So 1 times 10, 10 times 10. So it's times 10 is the rule. And if I continue to do that, this is going to be 1,000, this is going to be 10,000, and that's the next two terms. Please let me know if you have any questions on any of these problems. Have a great day.